Number 2, let f and g be the functions defined by f of x and g of x. Let r and s be the two regions enclosed by the graphs of f and g as shown in the figure above. Part A says to find the sum of the areas of regions r and s. So sum of the areas means we're going to find the area of r and find the area of s and add them together. So first thing I want to do is find this point of intersection. That's going to happen at, if you use intersect on your calculator, this will be 1.03283. Okay, and we always want to go to at least 5 places when we're using that point of intersection. So when we want to find the intersection, we are going to do, to get the area, we're going to do area will equal, the first area is going to go from 0 to 1.03283, and I notice that g of x is on top on this one, and if you graphed it you would be able to see that. So we're going to do g of x minus f of x, always dx, plus, and then the second area is going to go from 1.03283 to 2, and this time f is on top, so this is going to be f of x minus g of x dx. And now you can just go ahead and calculate that. When you do that, you're going to get 2.004. That was worth actually 4 points. You got 1 for getting the correct limits, so if you have the limits correct on both of those, you'd get a point. You're going to get 1 point for each integral that you set up, and then you're going to get 1 point for the correct answer. Okay, number 2, region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. So we know we're going to, when we find the volume, they're perpendicular to the x-axis, so we want everything in terms of x, which they are, which is great. We're going to be going, we're just dealing with region S this time, so just this region. Okay, I'm going to be, so that means I'm going to be going from 1.03283 to 2, okay, and then we know that the area of a square is side squared, so we'll be putting side squared there, and in this case we'll have 1.03283 to 2. Our side squared would be the top minus the bottom, so the top minus the bottom will be f of x minus g of x, and it will be that quantity squared. And then from here we can use math 9, and we should get for this one 1.283. All right, so we're going to get 2 points for our integrand. So this 2 points for getting this set up. Maybe if you had it backwards, you'd get one of the 2 points. So 2 points for this, and then 1 point for the correct answer. Then part C, let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to h when x equals 1.8. So the vertical distance is just this distance right here. It's just going to be the y value minus the y value. So just kind of like what we did on area, it's just going to be the top minus the bottom. That will be h. So h is going to equal f of x minus g of x. All right. When it says find the rate at which h changes, that's asking for h prime. We would usually put dh dt, but it's not with respect to time this time. It's just with respect to h. So then h prime would equal the derivative of f of x would be f prime of x. The derivative of g of x would be g prime of x. And now we just want to calculate this at 1.8. So h prime of 1.8 would equal f prime of 1.8 minus g prime of 1.8. To calculate that, we can just do math 8. We don't have to do a lot of work by hand at all because we get to use our calculators, and we should get negative 3.812. So that was worth 2 points. If you found h prime, that was worth 1 point, and if you correctly found the answer, that was worth another point.